So eventually, after a couple of weeks go by, and I asked someone, why don't you guys have solar panels in Dublin? And this person asked me, how long have you been here, kid? And I was like, well, a couple of weeks. And I said, well, this is what winter in Houlton looks like, right? Sometimes it happens, and then all the kids are happy. I had never seen snow before I came up here, by the way. So you can imagine how I felt. Actually, the first few days, I felt like a Disney princess, right? There's all this gently falling snow, and I was jumping around, being all happy, and then wind started blowing, and started being really cold, and I couldn't take it anymore. But in any case, so he said, we get a lot of snow, 250, 300 inches of snow. Snow covers your solar panels. They don't make enough energy. Therefore, we don't have solar panels. And I didn't know enough about solar or snow. And so I said, sure, of course, that makes sense. Yeah, perfect sense. For the first 2 years, I stayed on campus, never paid a single electric bill in my life. After 2 years, I moved to downtown Houlton, right? My first electric bill is $233. This can't be right. They misplaced a decimal or something. $233 can feed like a family of 28 in India, right? This is obviously a mistake. And so I go to the utility company. And of course, they're like, well, how long have you been here? Okay, 2 years, but you never paid a bill. And then, they found out that the electric rates up here in Western UP and parts of the Kiona are some of the highest in the state. I want to pat myself on the back for color coordinating these things. So what you see here, this blue bits is where we live, and that corresponds to the electric rate from this utility company. So the hollow bars you see there are what are known as rural electric companies, and the bars that are filled in are privately owned utility companies. And up here, we are serviced by these two, which happen to be some of the highest in the state. Not only that, they also are higher than the average electric rates of about 49 different states in the country, with the only exception of Hawaii, which happens to suffer from the misfortune of being an island in the middle of nowhere, which sometimes also describes the Kiona. Right? So I'm thinking, I'm sitting there and I'm thinking, okay, well, maybe I can put solar panels on my roof and I can help mitigate some of the costs of electricity. So what I do is I'm consumed by this desire to try to get snow off of solar panels, right? That's what I'm thinking back then. And so we have this facility here, the Kiona Research Center, right near the airport. We have the solar panels. Some of these are designed to mimic a rooftop installation, so they're flush against the roof between 0, 15, 30, and 45 degrees of inclination. And these are ground-mounted systems between 15 and 45 degrees, and they have data going back to a few years. And so I went back, I looked at the data, and I'm trying to figure out, if I can change the angles on my panels so I can get rid of the snow. And so when you think about it, right, the sun is higher in the sky in the summer on an average day, and it's lower in the sky in the winter. So if you wanted to point a solar panel towards the sun better, in the summer you would want to go lower because then you're pointing at the sun better. In the winters you want to go at a higher angle because then you're pointing at the sun better. Now, not only do you point towards the sun better, but two other things also happen when you put your solar panels at a higher angle. One is that snow reflects a lot of incident sunlight. As you can see here, it reflects between 80 to 90% of sunlight. So this graph here, the blue line represents just direct sunlight on the solar panel. The orange light here represents the sunlight that is reflected from the ground around. So as the higher you point this way, the more you're pointing towards the ground, so you also capture a lot of reflected sunlight. What happens is your snow also sheds better. Right? The solar panel is the higher angle. The surface of a solar panel is almost glass, and so snow slides are relatively easier from a 45-degree inclined panel than compared to the other ones. So I put this together, and I put this together in the form of a neat little report, and I said, oh, well, in the winters, if we had the ability to change your angle higher, summers put it lower, and I was really happy about it, and I showed it to my boss, and then we found out that it actually doesn't matter at all. It doesn't matter how much snow there's on your solar panel. And I noticed actually some of you, sorry, I didn't mean to pick on you, but some of you have a really skeptical look on your face. It's okay, because that's exactly the same face that my boss also made when I first told him this thing. The reason it doesn't matter is because this is the percentage of sunlight that we get by the month, right? 100% through the year, and this is by the month. Now, in the winter months, only accounts, so November, December, Jan, and Feb only accounts for about 8% of all incident sunlight up here. So even if you didn't have any snow at all on your solar panels, it might not make that much of a difference.